Welcome to a little review of single replacement reactions. A piece of copper is dropped into a container of water. So we have two reactants here. We have copper and we have water. Remember, copper is going to be represented as Cu, is dropped into a container where we can consider that a plus, and then water is H2O. Now when we think about this reaction, we remember back to what you learned in Regents chemistry about activity. So copper is less active than hydrogen. So will this reaction even happen? No, it will not. So no reaction occurs. Liquid bromine is added to a container of sodium iodide crystals. Liquid bromine is the state that bromine exists at STP. Now remember, bromine is a diatomic. So we're going to write Br2. So liquid bromine is added to a container of sodium iodide crystals. So sodium is Na plus 1, iodine is I minus 1, so we can write NaI. This reaction is going to happen because bromine is more active than iodine. When you think about group 17, bromine is higher in the group than iodine is, so bromine has the ability to replace iodine and form a compound with Na. So as a result, one of our products here will be NaBr, because Na is plus 1, Br is minus 1. Iodine gets kicked out basically of this reaction, and remember that iodine is also a diatomic, so we're going to write I2. Now, we cannot just stop right there. This equation is not balanced. So in order to balance this, we have to look at this and say, I have two bromine on my reactant side, so I need a bromine in front of the Na2Br, and I have two iodines on the product side, so I'm going to need a 2 on the reactant side. So as a result, I can look at this whole thing and say it is balanced. Let's go on to the next one. An aluminum strip is immersed in a solution of silver nitrate. So aluminum strip, that's just aluminum metal. We're going to write the symbol for aluminum, which is Al, plus silver nitrate. Now remember, silver is Ag plus 1. Nitrate is a polyatomic, so NO3 minus 1. So as a result, our compound here is AgNO3. Arrow to say, hey, this reaction is going to happen. Why is it going to happen? Because aluminum is more active than silver is. So aluminum will be able to kick the silver out. One of our products will be silver metal. Now we have to be careful here. Aluminum has a plus 3 charge, Al plus 3. The nitrate polyatomic is NO3 minus 1. So when we work this formula as we cross down, remember our mantra, no positives, no negatives, no ones. So we have to make sure that we put the NO3 in parentheses here to represent that there are 3 nitrate polyatomic ions for every 1 aluminum ion. When we write this, it's going to be AlNO3, and then I have to go back and balance it. 3 nitrates on the product side. I'm going to need to put a 3 in front of my silver nitrate, and as a result I need to balance my silver, and the aluminum is balanced out. Let's look at the next problem. Zinc pellets are added to sulfuric acid solution. Zinc is a metal, so we're just going to represent it as the element symbol, plus sulfuric acid. You should know the formula for that, which is H2SO4. This reaction will happen because zinc is more active than the hydrogen here. So the zinc is going to come in, it's going to kick out the hydrogen. As a result, hydrogen gas is released. Now don't think that hydrogen here is a polyatomic. It is not. It is H plus 1. This 2 right here is coming from the sulfate ion because we know sulfate is SO4 minus 2. So be wary of that. That's incorrect to assume that there's a diatomic in this formula for sulfuric acid. When we write the formula that results as our other product, we remember that Zn is plus 2, sulfate SO4 is minus 2. The plus 2 and the minus 2 are going to cancel. Therefore, my final product is ZnSO4. I need to go back and check that everything is balanced. 1 ZN, 1 ZN, 2 H's, 2 H's, 1 SO4, 1 SO4. I'm good and I'm balanced. Let's look at our next problem. Fluorine gas is bubbled into a solution of aluminum chloride. Fluorine is a diatomic, so F2. Bubbled into a solution, we're going to represent that with a plus. Aluminum chloride, Al plus 3, Cl minus 1. So I need to cross these down. So this will be AlCl3. Half the battle is making sure that you write the correct formula. So it's always worth to take a second to do this just to make sure that we have written the correct formula. In this case, this is a nonmetal replacing another nonmetal. Fluorine is the most active nonmetal on the table. Fluorine has the ability to come in and kick out the chlorine. As a result, chlorine will appear as a product and be represented as a diatomic. Fluorine will then form a compound with the aluminum. So we have Al plus 3, Al plus 3, F minus 1. So when we cross this down, it's going to be AlF3. This reaction definitely will happen. So what do I have to do here to balance this? I have 3 chlorines on my reactant side. I have 2 chlorines on my product side. I know that the lowest number that those both will divide into is 6. So I'm going to put a 2 here, and I'm going to put a 3 here. Same situation with the fluorines. I have 2 on the reactant side. I have a 3 on the product side. I'm going to put a 2 here to give me 6 fluoride ions on the product side. I'm going to put a 3 here to balance the fluorines right here. And I can see here and here that the aluminum has been balanced. Let's look at the next one. Magnesium turnings are added to a solution of lead 2 acetate. So magnesium can be represented as Mg, added to a solution of lead 2 acetate. Okay, lead is represented as Pb plus 2. Acetate is C2H3O2 minus 1. So I'm going to cross those down. So my formula over here will be Pb C2H3O2, and then I'm going to have a subscripted 2 here, and then an arrow. Magnesium is more active than lead, so magnesium has the ability to come in and kick out the lead. As a result, we're going to have lead as one of our products, right there, and the magnesium is going to hook up with the acetate. Now remember, magnesium is Mg plus 2, so we're going to have a very similar situation to what we see here. So this is going to be Mg, and then the acetate, C2H3O2, surrounded in parentheses with a subscripted 2 on the outside. And by looking at this, by inspection, everything is balanced. Let's look at our next problem. Iodine crystals are added to a solution of sodium chloride. Alright, iodine is represented as I2, added to a solution of sodium chloride, so that's going to be NaCl, and no reaction is going to take place here. No reaction. Why, might you ask? Iodine is not active enough to replace this chloride ion here, so it's just going to remain as I2 and no interaction will take place. Let's go on to the next one. Calcium metal is added to a solution of nitrous acid. Calcium metal can be represented as Ca and then plus, and then nitrous acid is HNO2 and then an arrow. Calcium is more active than hydrogen, so calcium can come in and kick out the hydrogen. So hydrogen will be released, hydrogen gas will be released. This is going to be CaNO2. Going back to balance, I have 2 nitrate ions over on this side, so I'm going to put a 2 in front of here. The Ca is already balanced, and by putting the 2 in front of the HNO2, my hydrogens are balanced. Last 2. A pea-sized piece of lithium is added to water. Lithium is going to be represented as Li, added to water plus H2O. The The lithium is definitely more active than the hydrogen is, so the lithium is going to come in and kick out the hydrogen. As a result, hydrogen gas is going to be released, H2, and our other product here is going to be LiOH. Now this is a very common type of reaction where we have a group 1 metal being added to water. This turns into a very basic solution and hydrogen gas is released. When we go back to balance this, we see that we have 2 hydrogens on the reactant side and a total of 3 hydrogens on the product side. We don't want that. We need to have an even number. So if I put a 2 in front of here, now I have 4 hydrogens. So I'm going to put a 2 in front of here. And let's see, my hydrogens are balanced, 2 oxygens. By putting that 2 in front of LiOH, my oxygens are balanced, 2 Li. I'm going to put a 2 in front of here, and I'm good, and I'm balanced. Last one. A solution of iron 3 chloride is poured over a piece of platinum wire. One of our reactants is going to be iron 3 chloride, so iron is Fe plus 3. Chloride is Cl minus 1, so when we cross these down, one of our reactants is going to be FeCl3, poured over a piece of platinum wire. So plus, and then platinum is represented as Pt, and then an arrow. Pt is not as active as iron is. Platinum is pretty low on the activity series, so as a result, no reaction occurs.